Clearing fractions. In this video, you will learn how to solve equations with multiple fractions in an efficient way. Recall that if you saw this equation, most of you would probably subtract 5 from both sides, so we'd have x divided by 4 equals 3. Then you would multiply 4 on both sides to cancel out the 4 in the denominator and get x equals 12. However, a different way to solve this problem would be to multiply by 4 at the beginning of the problem. However, if we do it to one term, we have to do it to every term across the entire equation. So we get x plus 20 equals 32. Now when we subtract 20 from both sides, we still get x equals 12. We're going to use this method and apply this to equations that have multiple fractions and often multiple different denominators. When we solve equations involving fractions, or do any work with fractions, many of our mistakes end up being careless calculation errors. So one way to avoid this is to get rid of fractions at the beginning of the problem. Our steps are going to be to identify the least common denominator, create a common denominator for every term. Really, we're going to skip this step. Multiply every term by the least common denominator to clear all of the denominators, and then solve the remaining equation. So in this first problem, my least common denominator is 3. That's the only denominator we see, although we know that 7 is really over 1. This tells me that I can multiply every single term here by 3 to cancel out my denominators, and this leaves me with 2x plus 21 equals 5. Then I'll continue solving from there, and I get x equals negative 8. Now, before I said create a common denominator for every term. If we had done this here, then we would have made that middle term 21 over 3. Although I'm not showing that step out, you can imagine that that's what we're doing here, and since all of the denominators are the same, when we multiply each term by that 3, we end up with just the numerator here. However, this is the way that we're going to do our workout. Let's continue with the next problem. The first step is to identify the least common denominator. You might also think of this as the least common multiple of the denominator. My denominators are 2, 3, and 6, so their least common multiple is 6. That's divisible by 2, 3, and 6. So I'm going to multiply every single term by 6. I make sure not to miss any terms along the way. Notice that now I need to do some cross-canceling here. So I would have 18 over 2. In other words, I'm left with a factor of 3 in my numerator. Here, I would cross-cancel, and I'd be left with a factor of 2 in my numerator. And here, my 6's cancel. So my next line is 9 plus 4x equals 13. And I can continue to solve from there. Because this video is focusing on clearing fractions, I'm not explaining my steps once we get to a two-step equation. The main focus here is to figure out how to get rid of the multiple denominators. Keep in mind that if you were to check this solution x equals 1, you'd want to check it in your original equation here in case you made a mistake with the fractions. Let's continue with a more complex example. When I look at this problem, although it appears that I have 3 denominators, I really have a 4th denominator right here with the negative 2x. I would suggest that you always write this over 1 because I often see that people write multiplying by the least common multiple and they forget the term where there's not a denominator written. It is very important to remember to multiply this term or your solution is going to be totally off. I multiplied by 8 here because that is my least common multiple or my least common denominator here. That was 8. So now I have this equation. These will cancel, so I have 7 plus, these will cancel, leaving me with a 4x, equals negative 16x plus 2. You'll notice that you'll start to do a lot of mental math here. And I continued the problem to get the solution, x equals negative 1/4. Again, I'm not going to explain all of those steps. The focus of this video is up here. This next problem can be a little bit tricky. When you see a fraction bar with multiple terms in the numerator, imagine that that whole thing is in parentheses. That means that I have 4 over 1 minus 4 plus 3x, which are both over 2. I could even write it as 4 over 2 plus 3x over 2. Many of you might find it helpful to write out the problem in this way and deal with these as separate terms. If not, just remember that this is one denominator, so you're going to multiply it once and distribute that negative. Since my denominators are 1, 2, and 5, that means that my least common denominator, or least common multiple of the denominator, is 10. So I'd multiply 10 to each separate denominator here, just like before we were doing our separate terms. I'll do a little bit of cross-canceling ahead of time to make it easier for myself as I solve. So I can cancel this to be a 1 in the denominator and a 5 as a coefficient, and a 1 in the denominator and a 2 as a coefficient. That makes my equation 40 minus 5, and don't forget we're going to have to distribute that negative 5 equals 8 like this. If I was doing this other way, don't forget that I would multiply each of these by 10, and we should end up with the same thing. Pause the video, try to complete this problem on your own. The solution that I got was 12/15 or 4/5. This would be a bit of a pain to check, but again, if we wanted to check our solution, we would put it back into the original equation here. These problems can be very tricky. I'm going to skip example 5 if you have the same examples as me and go on to example 6 as my final example. I'll show you 2 ways to approach this problem. The first way would be to get rid of the fractions at the start. I know that this will be an efficient way because if I distributed 1/3, I can see that I'd end up with fractions right here. So what I need to figure out is what is my least common multiple of my denominators. However, since this fraction is going to be distributed, the denominator of both the 4x and the 10 is actually a 3. Since this fraction is going to be distributed, the denominator of the x and the negative 4 are both 2, although we could simplify the negative 4 with the 2. So I need to figure out what is the least common multiple of 3, 1, and 2, and that would be 6. So I need to multiply by 6 here. I won't do it to each of the terms in the parentheses because then I would be multiplying by 6 twice since this is already going to be distributed in. I'll multiply it to the 7 and I'll multiply it to the 1/2. That means that really I'm distributing a 2 to the 4x minus 10, and I have equals 42 plus 3 times the x minus 4. Now I'll continue solving from here. However, I could have done a different method to start. I could have taken the original problem and distributed in the fractions. That would have given me 4x over 3 minus 10 over 3 equals 7 over 1 plus x over 2 minus 4 over 2. Now I could simplify the negative 4 over 2 to be 2 over 1, but it won't change my least common denominator because I have a denominator of 2 right here. Then I could multiply each term by our least common denominator, or least common multiple, 6, giving me 8x minus 20 equals 42 plus 3x minus 12. That's the same thing that I'll get here. 8x minus 20 equals 42 plus 3x minus 12. It doesn't matter which of these two methods you choose. Pick the one that makes more sense to you. If you struggle with seeing a problem like this, where we have parentheses and you don't remember how many times you should multiply or where you should multiply by the least common multiple, then I recommend that you distribute first so you have all separate terms. One other side note is you might see a problem that has fraction bars in it. You might see this, 4x minus 10 over this fraction bar equals 7 plus x minus 4 over this fraction bar. That's equivalent. That is equivalent to the problem that we just saw. So again, a fraction bar could always be split where each term has that denominator, or you could pull out that 3 in the denominator to be a 1/3 out front. These problems can get tricky, so you want to make sure that you find a method that works for you, but you also want to make sure that you are using a method that is efficient. I would suggest that you practice your new skill on your own with some of these problems. You might have the notebook that I have, so you could try some of the problems that you see here and check them with the key provided. Or you may have a packet from your teacher and you could try some problems there. Notice that we start out with problems that aren't as complex because we have all separate terms. But as you see parentheses and you see fraction bars, the problems get trickier, so you may want to pace yourself with some of the more basic separate fraction problems first before moving on to problems like the ones farther down. Thanks for watching.